Friends, very good morning to everyone. Today's subject of discussion is pericyclic reaction. As the name indicates, these are reactions in which pericycles are involved. These pericyclic reactions are concerted reactions, means it takes place in a single step. It involves the reorganization of the electrons, and there is no intermediate formed. Instead, a transition state which is cyclic is formed in the process of conversion of the starting material into the product. There are key features which makes pericyclic reactions different from others. What are these features? As we have seen, there is no intermediate form. It is a single transition state which is formed. Here, the bond breaking and bond making involving both sigma bond and pi bonds occurs simultaneously in a cyclic transition state. Another salient feature of pericyclic reaction is that the products which are formed are highly stereospecific. The specificity of the configuration of the product depends upon the initial configuration of the reactant and the number of pairs of electrons which are involved in the reorganization and the reaction conditions, whether it is induced thermally or photochemically. These are the reactions which can be induced either thermally or photochemically. The reagents which we use do not affect the reaction. These are the three parameters which affects this reaction. Let us see few examples. The Ts which we represent here is transition state. There are various types of pericyclic reactions. The classic type is cycloaddition reactions. The second type are electrocyclic reactions. The third, sigmatropic rearrangements, group transfer reactions, chelotropic reactions, and diatropic rearrangements. The cycloaddition reaction is a classical example is Diels-Alder reaction. Here, a diene, one, two, three, four, four carbons it has, it's a butane, and at one position and three position, it is having double bonds. That's why it is 1,3-butadiene, and an ethene. This acts as a dienophile and this acts as a diene. A diene and dienophile reacts together when it is heated. The pi electrons in the diene moves towards the alkene carbon and the pi electrons in the alkene carbon moves towards the other end of the diene, and It has to maintain its status and the pi electrons in this position moves towards the next position. There is the reorganization of electrons. When reorganization occurs, the new sigma bond is formed between this alkene and the diene. These are the two sigma bonds which are formed, and these two pi electrons have got reorganized and it formed a this double bond over here has been shifted to the next position. Overall, two sigma bonds are formed at the expense of two pi bonds, and this reaction is reversible. If I heat this cyclohexene, I can get back the butadiene and the ethene. This is another important feature of pericyclic reactions. All are reversible. The electrocyclic reactions are intramolecular reactions. In cycloaddition, two molecules are involved, that is a butadiene and an dienophile. Here, a single molecule is involved. It reorganizes its electrons when it is heated. The pi electrons in this system are in conjugated form. This conjugated compounds reorganization of the electrons takes place in the when it is heated. The pi electrons moves to the next carbon to maintain its valency. The pi electrons again moves to the next carbon, and again these pi electrons moves to the next carbon. In the process of reorganization of the electrons, a new sigma bond is formed at the expense of one pi bond, and the reorganization of the position of the pi bonds has occurred. This is formation of cyclohexane by heating hexa 135 triene. Cyclic compound is formed by the pi bond per pi electrons reorganization. That's it is called as electrocyclic reactions. Only single molecule is involved, that's why it is intramolecular reaction. There is rearrangement of pi electrons in the open conjugated system. This is a compound which is not cyclic, it is open and it has conjugated double bonds. And when it is heated, it forms the cyclic product. Here I have seen a new sigma bond is formed at the expense of one pi bond. Here there are three pi electrons. In the product there are two pi electrons. Here new sigma bond is formed in the product and one sigma bond pi bond has got lost in the starting material. The reversible reaction is also equally true and it occurs. The formed cyclohexadiene, when it heated, it gets converted back to hexa 135 triene. This is reverse of electrocyclic reaction, that's it is called as retro-electrocyclic reactions. Sigmatropic rearrangements, as the name indicates, rearrangement takes place. And this rearrangement is intramolecular. Within the molecule, the rearrangement takes place. Here, in this kind of compounds, which has double bonds and they are not conjugated with each other. The pi electrons moves and forms the bond with the adjacent carbon. To maintain its valency, the pi electrons over here moves to the next position, and the bond here, the sigma bond, breaks and moves to the next position. In the process, the sigma bond at this position has got shifted to this position. The starting material has two pi bonds, and the product is also having two pi bonds. This is the new sigma bond formed, and no pi bonds has been reduced. The sigma bond position has got shifted. This is called as Cope rearrangement. It is a concerted reaction which is unimolecular, and these are isomers. That's why it is an isomerization reaction. It is characterized by the movement of sigma bond from one position to the other position. The accompanying rearrangement of pi electrons has taken place, and the new sigma bond has been formed, and the double bonds in the starting material and the products remain same. Sigma bond has been shifted from one position to other position. That's why it is called as sigma-tropic rearrangement. The group transfer reactions, here propene reacts with ethene when it is heated. The carbon hydrogen in propene gets shifted towards the ethene. When this bond has got shifted, the pi electrons moves towards this carbon of the propene, and the pi electrons in the propene moves to the next position. It gives rise to a new molecule. The carbon hydrogen in propene has shifted to the ethene, and the pi bond in the ethene has got converted to sigma bond. Here the sigma bond shift has occurred, and at the same time new sigma bond is formed at the expense of one pi bond. It is the new sigma bond which has got shifted, and this is the new sigma bond which is formed, and this is in reaction between propene and ethene to give one pentene. Here the CH group has got transferred from propene to ethene, and propene and ethene are again interconnected to the with each other with through a new sigma bond which is formed. It resembles sigmatropic rearrangement as the bond has shifted, sigma bond has been shifted from this to this. But there is, it is sigmatropic rearrangement is intramolecular, here it is intermolecular, or it is bimolecular. Group transfer has occurred in a single concerted step, and a new sigma bond is formed at the expense of one pi bond, and this is another type of pericyclic reaction. It has the characteristic of both sigmatropic rearrangement and also the electrocyclic reaction. Chelotropic reactions are another type of electrocyclic reactions. Here, like cycloaddition reaction, diene is involved. Instead of ethene, it is having an atom with lone pair of electrons, sulfur dioxide. Sulfur has lone pair of electrons. The pi electrons in ethene, in case of Diels-Alder reaction, we use ethene. Ethene has pi electrons, and those pi electrons in ethene is replaced with a single atom with lone pair of electrons. There, the two sigma bonds are formed towards this ethene carbon. Here, this lone pair of electrons forms bond with the carbon of the diene, and the pi electrons moves to the next position, and it makes the pi electrons in the next position to get converted towards the sulfur, and the two sigma bonds are formed with the rearrangement of the pi electrons, which are conjugated with each other, and the lone pair of electrons on the sigma on the sulfur has got disappeared. The reversible addition of sulfur dioxide to 1,3-butadiene is an example for chelotropic reaction. In this reaction, lone pair of sulfur atom is equivalent to pi bond and is reorganized. Pi bonds and the lone pair of electron disappears, and the new two sigma bonds are formed. The sulfur oxidation state gets converted from +4 to +6. The last type of electrocyclic reaction is, or pericyclic reaction is, diatropic rearrangement. In diatropic rearrangement, there is no formation of either a new sigma bond, or there is no utilization of either a pi bonds. It is just the shift of the sigma bonds from one position to other position in a single concerted step, or it can occur in two steps too. Here, these are two types. The first type, the CR over here will get shifted to this R dash, and the interchange of R and R dash occurs. Two groups migrate to the opposite positions. Another type is, there is exchange of position of the groups. Here there is no exchange. The CH and CD bond at this position gets shifted to the next position. And here the double bond over here has got shifted to here. Interchange of pi electrons with that of the sigma electrons has taken place. Only the position has got shift, and it is completely intramolecular. These are the 7 varieties of pericyclic reactions which are here. When we compare in cycloaddition reaction, two new sigma bonds are formed at the expense of two pi bonds, and it is both intermolecular and intramolecular. Forward reaction is inter, and backward reaction is intramolecular. Electrocyclic reactions, a new sigma bond is formed at the expense of a pi bond, and it is purely intramolecular reaction. In sigmatropic reaction, there is no new sigma bond and there is no loss of pi electrons. There is only the migration of the sigma electrons from one position to the other position, and is purely intramolecular. Group transfer reaction, in this, one sigma bond is formed at the expense of one pi bond, and the group transfer has occurred from one molecule to the other molecule. In chelotropic reaction, two new sigma bonds are formed at the expense of one pi bond and one lone pair of electrons. In diatropic reaction like that of sigmatropic reaction, the two neither the sigma bonds nor the pi bonds have been utilized. The shift of the sigma bonds have got occurred. And how these reactions occur? What is the mechanism? As there are no reaction intermediates formed in this reaction, there is only a transition state and the reorganization of the pi electrons occurs during the transition state. And the cyclic transition states are formed. That's why they are called as pericyclic reactions. How it occurs? Why they are highly stereospecific? Some reactions of pericyclic nature are induced thermally, some are induced photolytically, and some are induced by both the methods. When they get induced by thermal method, they give a single type of configuration. When they get induced by photolytic method, they give different configuration compounds. Why is it? How is it? Will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.